Hi everyone. So in this video basically we will combine both the OLED display and moisture level sensor code, and we will display the moisture sensor value in the OLED display. So basically what I will do is that I'll basically use the existing example code of the OLED, and in that integrate the moisture sensor code that we have written earlier. So let's start. As you can see, this is the complete code. So basically I will not going to explain the whole level display code, OLED display. Just I'll show how to integrate it with the moisture, how to integrate the display code with the moisture sensor. Okay, so basically first let's see what I have added to the existing display code. That was the ESP32 example. So basically I am using an SSD 1306 display, so this code is easily available in the examples. So now I'll just add a few functions and libraries to integrate it with the OLED. So firstly what I have added to the existing code is the driver ADC function and ESP ADC function. So this is added, as you know, in the last video where we did use this function for ADC calibration for the moisture sensor. So that's why I've added these libraries here. So what else I have added? I have I have added these functions, these definitions. This is your default VREF number of samples. These are all same from the last video. There is no change here. I have added these 5. Okay, then in the below what I have done, okay, now let's see. Okay, so here the rest of the things remain same. I have just added 2 more functions below, then we'll just go to the app main function. So first function that I have added is a void display moisture value. Here I am passing 2 pointer, that is this one DISP, and the second is the ADC CAS pointer. So let's understand the core components of these two. This DISP parameter, this parameter is a pointer to the LVGL display structure. So LVGL is a basically library used in embedded for displaying purposes. Okay, so this is very common in creating it is basically very common library in creating graphic user interfaces, like those you find in smartwatches, home appliances. Think of LVGL as a toolbox that lets you draw shape, text, buttons and more on a screen. So what is DISP_T that we have used here? Basically imagine this as a reference or handle to your entire screen or display, and why it's used, it's like saying, hey LVGL, I'm talking about this screen. If you have more than one screen, each one gets its own LV_DISP_T, so LVGL knows which one you are referring to. A simple analogy would be, if you have 2 notebooks, LVDISP_T is like the label on the cover of each notebook that tells you which notebook you are going to write in. The second one which I want you to understand is this LV_object_T. So what is this? This is a bit more general. It's a reference to any object you might want to show on the screen. This could be a button, a label, which is a text basically, that we want to display, basically moisture percentage. It could be a slider or even a container holding other objects. And why it's used? It's LVGL's way of keeping track of all the things you have drawn or placed on the screen. When you create something like a button, LVGL gives you a LV object T, so you can tell it, move this button here or change the text on that label. A simple analogy would be if LV_DISP_T was the label on your notebook, LV objective would be a sticky note. You can place many sticky notes inside your notebook or objects on your display, move them around, write on them, or even put a smaller note on top of another. And how they work together? Basically, when you're programming the LVGL, you start by telling LVGL about your screen, that is LV disp_T. Then when you want to put something on the screen, you create the objects. LVGL needs to know where to put each object, so it uses LV disp_T to keep everything organized on the right screen. Okay, so this is the two things that I want you to understand before we move forward. This is the same one as we used earlier in the last video, so I'm not going to explain this. So then we are creating basically a label, basically to write the moisture value. And in this label we are first we are checking if the label is there or not. If it is not, then we are creating one, and then we are aligning it. Okay, this remains from here to here the same code I have integrated for moisture calculation as did in the earlier video. After that, from here on I am basically displaying on the label what I want to display, basically the moisture value, the moisture percentage. Okay, the second is the moisture monitor task. Basically here in this moisture monitor task, firstly we are passing this pointer. This is basically this is a void pointer, which means it can point to any to data of any type. In C, a void pointer is used for generic data operations because it can be cast to any other pointer type without an explicit cast. And PV parameter, this is the name given to this void pointer. The PV prefix is a naming convention used in the FreeRTOS, typically standing for pointer to variable or pointer void, indicating that this pointer is meant to point to some variable or data structure. So basically, when you create a new task like X task create, one of the parameters you can pass to this function is a void star pointer that points to the data you wish to pass to the task. This void is then received by the task function as its parameter. Inside the task function, you typically cast this void back to the appropriate type so that you can access the data it points to. So how it's used? Basically, what we are doing is, in this line, why we are using, we are this is we are casting so basically here the tasks were designed with the knowledge that it will receive this LV DSP pointer as its parameter. After casting, display can be just used like any other LV_display_T pointer in the LVGL related code, enabling the task to manage display content such as showing and updating. So basically, why are we using a void pointer? Because it is maximally flexible and hardware agnostic, supporting a wide range of applications. Using void pointer for task parameters allow any type of data to be passed to the task, from simple integer to complex structure, without changing the task creation API. This design supports complex applications where tasks might require varied and multiple pieces of data to operate. So basically, what we are doing here, basically here we are receiving a void pointer. We can send anything, and after that we are just casting it back to the level display, LV display, to convert it to that, so it can be used further. After that we are just passing this pointer to the display moisture function. So we are basically passing the values and the ADC char value, and we are just calling this function every second, so our moisture value is getting updated and we are just displaying it every second. So this was the two functions that we have done. Now let's just go to the app main. In the app main, what I have extra added, basically I have added these ADC initializations, and after that after this we have what we have added is below here, I think so. Yes, rest of the things remain same, and what we have added is this X task create FreeRTOS file. Here we are what we are doing is it creates a new FreeRTOS task dedicated to monitoring moisture level. It passes DISP, the display structure, to our task, enabling it to update the OLED screen with the latest moisture data. Okay, it sets the task priority, stack size. This is the stack size, this is the priority. Operation has its sources as it runs smoothly. So basically this is what we are doing here. And in the last also we are again calling this display moisture value function, because it's all about user experience. By updating the display immediately, we provide instant feedback when the system starts up, reassuring that the user that the device is operational and the moisture sensor is active. So this is the whole integration that I have done. So thank you. Now I'll meet you in the next video.